questions answered. So today is technically the last day of class. The final exam, of course, is on Wednesday morning. Hold on there. That thumbnail doesn't want to go away. It's funny, the mouse on this computer works sometime. I've actually clicked on the same thing about 30 times now. I can't get to hide the thumb. There we go. The Surface Pro picture is great. The mouse is worthless. It fails on me often. So the first question was, can I draw a picture with 5 vertices of the following degree? Now, the problem with a question like this is a lot of folks said, well, I'm going to either be able to draw this or I will not physically be able to draw this. And they're going to base their answer on their ability to draw this. That's kind of dangerous because your ability to answer a question has nothing to do with the validity of your answer. That's kind of like saying in algebra, I'm going to give you an equation and ask you to solve it, and you're unable to solve it. Therefore, it has no solution. Having no solution has nothing to do with your ability to solve it or not. Your ability to solve it means you understand the math involved. Your ability to draw this is nice, but I could have made 100 vertices of degrees in the millions, and I'm pretty sure no one would draw that one. No, the reason this does have an Euler circuit is I said it's a connected graph. That's the first thing. It has to be connected. And second, all of my vertices are of even degree. Okay. I don't have to physically draw it. That's a theorem. If I have a connected graph where every vertex is of even degree, it has an Euler circuit. You can't prove it by trying to draw it because, again, I could make the vertices have ridiculously large degrees, and I could make a ridiculous number of vertices, in which case it would be very difficult to draw. Similar to the previous quiz where we had the whole idea of, can you have this many friends? And I had people drawing a picture and saying, yep, I was able to draw a picture, therefore. I asked a question, I think, with 9 people and 4 friends. Well, what if I had said 9,000 people? You're not going to draw a picture in that case. So that's not a great way to do it. So now the second question, we used 2, 2, 3, 4, 4. And again, I had a lot of people trying to draw the picture and said, no, I wasn't able to draw the picture. Therefore, again, that doesn't have anything to do with anything. The reason this will not have an Euler circuit is because I have vertices of odd degree. That's it. That's the only answer you can possibly give has to do with the degree, because in both cases, I started by saying it's a connected graph. Now, if the graph were not connected, then it definitely doesn't have an Euler circuit. It'd be like saying I have 2 islands with no bridge between them. You can't get from one to the other without swimming through the water. Now, the third question, it was kind of tricky. I said, draw a connected graph and identify bridges, which means there actually must be bridges. Now, I said 4 vertices. Now, the most common picture I had people drawing was maybe something like this. This was probably the most common picture. Let's call that V1, V2, V3, V4. Now, a bridge is an edge whose removal makes the graph not connected. Okay, and it's that simple. Other folks drew pictures like this, kept it really simple. But then other people drew pictures like this. This has no bridges. But every single person who drew this picture also didn't identify that it didn't have bridges, which means we missed the point of the problem. To identify the bridges means got to have bridges. So this is a terrible answer, this one. So in this case, the bridge would be V1, V2, or V2, V3, or V2, V4. And then here, the same thing. If I remove any of these edges, it's not connected. So therefore, if I did something like this, well, let me connect these 2. Now let me connect these 2. Now let me connect these 2. This will no longer have any bridges because I can remove any edge without disconnecting the graph. So to be a bridge means you kind of have to think of it as a minimalist graph. And the easiest way to think about bridges is that you can have vertices that have degree 1. Anytime you have a vertex with degree 1, you have a bridge naturally because the only edge can be removed. So if all of my vertices are of even degree, there are no bridges. It's that simple. Now, the fourth one, this was a fairly simple one. It said, draw a graph with 4 vertices that is not connected. I think the majority of the pictures I got were usually something like this. That's a great picture. What about something like this? Would this still work? Yeah, it's kind of boring. There are no edges, but it's also not connected. I could also do something like this. That would also work. So any graph where you have a vertex or a piece of the graph that is not connected to the rest of it. So there's a lot of different ways you could have answered this question. Now, the last one says, draw a connected graph having 8 vertices with at least one Euler circuit. Now, what is required to have an Euler circuit again is that all the vertices have even degree and it is connected. And that's the key. It's got to be connected. So if all of the vertices have even degree, and let's say I go from here to here, then if I want more, then I've got to do something maybe like that. I can't have 3 edges. Now, as I move my way around, you can have a little bit of fun. You know, one of these things you drew when you were kids. And I keep going as long as I have even degree. Now, I can just have degree 2 if I choose. And maybe this one here you want. Okay, so well, I want to add one more. Well, right now I have 1, 2, 3, 4. I have 1, 2. I have 1, 2, 3. That's not going to work. I have 1, 2, 3. That's not going to work. So I need to do something. So perhaps, okay, I can go like this. You know, have a little bit of fun. But if each vertex has even degree and it is connected, then it's going to have an Euler circuit. And the fact is, it's going to have at least one Euler circuit. So if we wanted multiple Euler circuits, then you got to have a lot of edges. Okay, so this was supposed to be a pretty simple assignment, and same with the last one. And most people found it to be relatively simple. Again, there's more than one answer to this, as long as your answer fit the criteria. Again, a connected graph, every vertex has even degree. We know there exists an Euler circuit. You don't have to prove that. That's a theorem. Now, the final exam itself will appear like the last exam. I'm going to give you more problems than you have to do, and each problem will be worth the same. And part of the reason for that is so you don't make any one problem more important than any other problem, that you don't dwell on any particular solution. When you look at a problem, you either know how to solve it or you don't. If you don't know how to solve it, move on. You just can't have a long list of those. Okay. And the thing is, because every problem is worth the same, that gives you an idea about how to time it. Now, the final exam is you're going to have 2 full hours. It's a final exam. Okay. It's not just a last test. So I need you to have enough time to get through everything. Now, will you get through everything in 2 hours? Oh, yeah. Yeah. There's no possibility that you should even take 2 hours, but I don't want you to worry about running out of time or anything like that. The exam will start at 8. Now, if you have another final in another class that starts before 10 a.m., then you need to start my final before 8 a.m. And therefore you need to contact me. No one has contacted me about that yet. So I assume that nobody has that issue. But if you find yourself making it a close call, because I know in my Calc 3 class, for example, there are people that have their physics final literally 5 minutes after the Calc 3 final. That's kind of tough. So if you have a situation like that where your finals are so close together that it's uncomfortable, just let me know and we'll start the final a little bit earlier to allow you extra time. It doesn't make any difference to me. I'm up very early in the morning, so starting your test earlier isn't an issue at all. But I need to know that right away. I can't really adjust that on Wednesday morning. So every single thing that we did is fair game. There were 25 lectures in the course. So the way I want you to think about the final is, I'm going to take the most important topic or most important concept presented each class, and that would represent a final exam question. Quite literally, that's about how long the final is. It's around 25 questions. You're not going to do every question. You're going to do something less than that, maybe like 20 questions. And so if there are things you just never really got good at, maybe there were certain types of proofs, maybe proof by induction was something that was a thorn in your side, or proving that something was an equivalence relation. Maybe it was combinations in general troubled you, or expected values. If there was one topic that just really you didn't get, it's okay. You can afford to skip that as long as you are practicing and going over things. Now, in terms of formulas, I mentioned this last day, you may reuse your formula cards, but you shouldn't. You should make a brand new set of formulas. You get to use an 8.5 by 11 piece of paper, one side only, and write down theorems, formulas, definitions throughout the course. Now, this is where you literally want to go through every lecture and say, did we cover something here that I don't know inside and out? And in some cases, it could be theorems. In some cases, it could be definitions. There's terminology that you may or may not remember. Okay, something as simple as we're talking about, I give you a statement and I ask for the converse, the inverse, the contrapositive, the negation. Do you know exactly what that is? Now, you can't write down examples, but you can write down the definition. So here would be a simple example. If I said the conditional is P implies Q, then what is the converse? What is the inverse? What is the contrapositive? What is the negation? Okay, I'm not even giving you a statement, but what would the converse be? Well, that would be Q implies P. What would be the inverse? That would be not P implies not Q. What would be the contrapositive? That'd be not Q implies not P. And what would be the negation? That's P and not Q. Oh, this is not only the definition of what these terms mean, but this will get me to my conclusion much faster. This would be something you might put on a formula card or formula sheet, because it may be something that, was not your strong suit. You do not have to break down things like combinations and permutations and things like that. You don't necessarily have to break it down into the factorials. You just have to know what's the difference. Now, it might not be a bad idea to write down the formula for permutation and write down the formula for combination as separate things to make sure you remember combination is bigger, things like that. But whatever you choose to write down, excuse me, it should be theorems, formulas, definitions, not examples, not worked out problems, not problems that were on another test or quiz. Okay, that would make it open book, and that's not the case. That's why I ask you always to show me your formulas before you start, just to make sure that what you wrote is okay. If you just have your notebook in front of you and you can flip through the pages, no. That means that you were not responsible to remember anything. You could just look it up during the test. You can't do that. Now, yours is the first final I am giving, so I should be done with the finals relatively quickly. I can imagine I might be done with them before Thursday even. And because there are several people who are not going to take the final because they're happy with the grade they've earned. So if you need this result for anything else, it will be filed early on. Now, I do remind people about things like transcripts. If you are transferring in for the fall, which many of you are, okay, any transcript request that you put in, always make sure it's very clear that you want to include your spring grades. That's kind of automatic, but you still want to make sure that the person that you are referring to, if you're talking to somebody, it says include my spring grades. If you're going to be transferring for a summer course, okay, same thing. Although I can't imagine that this class is going to be a prereq for anything you might take in the summer, but just in case it is, again, you might need the grades. If for some reason things don't go your way and you need to retake this course, okay, same thing. The grades will be filed fairly early so that if that's a situation that you ended up having to retake the course, at least you would have the ability to do so. If you were planning on retaking the course at this point, you can't sign up until the grades are filed because you're currently in progress. So if you ended up with a D or an F in this course, the grade would already have to be processed and in before you could sign up for a course. Just, hopefully that's not the case with anybody here. Now, I've gone over what we need to go over. Does anybody have questions? So now I'm going to stop recording.